Good day and welcome back to another session of Down the Rabbit Hole with Building Inspector Steve Nason. Today we want to talk about ICF construction, foundations, and walls, and we're going to talk primarily with the ones without holes, if you want to call it, without windows or doors or whatever, because these sections are meant to be a little bit of a short introduction on ICF, and we'll dive down and look and see about National Building Code, and then a new manual that's out. It's called the Icfma Manual, and it's Insulating Concrete Forms Manufacturing Association. They've produced a new manual in 2021. So we'll take a look at those and see how you can design a wall with those. Anyway, as I said before, with these videos, they're meant for information only. You can take and do your own research, and so let's just get started. There's 4 ways to do the an ICF construction. You can do the prescriptive method. There's the National Building Code of Canada. You can also do the Insulated Concrete Forms Manufacturers Association Manual, again, which I said is that it's new in 2021. And that's a consortium of 6 manufacturers that have got together and decided to produce one manual, which for building inspectors and those and designers, that's great because we've got one-stop shopping. And even though all the manufacturers were pretty well the same, this still gives us one manual to get understand and work with. The other way you could do is a manufacturer's manual. So some of the manufacturers of an ICF block are not members of this association or have not contributed to this manual. But however, there is a little bit of a caveat that you have to watch to make sure that that manufacturer references the code of your jurisdiction, in like in New Brunswick here, where you are at the 215 code. So you want to make sure that's stamped in reference to that code cycle. The other one would be site specific. Okay, if you've got a unique site or whatever, you need to have a site specific engineering done, and that's be the 4th way. Okay, now there's a couple things that we need to know. Is that we need to know that that you're limited to 2 stories in height, single dwelling unit, 3 meters from floor to height. Okay, and where that comes from with ICF is in the materials, it's section 9.3, materials, systems, and equipment. They talk about it because once you put in rebar in a concrete wall, then you've turned that from a concrete wall into a reinforced concrete wall, and that reinforcement it limits us to those parameters. Once you, again, is that, and we'll go back into this, there is some talk about minimum lapping of bars and those things in that material section. Okay, now a couple things that we do need to know is we need to know the climatic data for your area, okay, and that's found in the National Building Code or in the Icfma manual. You'll find that in there. The only thing you won't find in the National Building Code is what they call a equivalent spectral response acceleration number, and that's only found in that Manufacturers Association manual. Okay, but all of the other data you'll need to know that as you design or review your ICF plans, and you'll also need to know a bearing pressure of the soil. Again, is that you know, in Atlantic Canada here, we get a lot of glacial till, and that is about 200 kips. So we need to know that and design that around that bearing pressures. You need to also know the tie spacing, the block height, and the wall thickness. Okay, so you need to know those. Okay, and then they talk about foundation wall thickness. Again, foundation wall thickness will be a minimum of 140 millimeters, right, in the thickness of concrete in the wall above. So again, is what they're trying to tell you, which makes common sense, that you can't have a 6-inch wall supporting an 8-inch wall. So that makes sense. Now the other one that I got a little bit of a star and a square around it is foundation walls made of flat insulating concrete formed shell, and that's a big word for building inspector. That's sort of like the line in the sand. So shall be laterally supported at the top. So again, as I got that a little bit of starred in there, so we'll go back at that. We'll go look at that, but you just want to put that in your little bit of memory bank and say shall. Okay, shall be laterally supported at the top. Okay, now with this one here, we'll look here and see that you can't any opening greater than 101.2 millimeters wide. This talks about openings shall be considered laterally unsupported, right? If you've got an opening that's greater than 1.2 meters wide, or if the areas of the accommodation of the walls are greater than 25%. Okay, so if this opening here was greater than 1.2 meters wide, then that section up here wouldn't be laterally supported. Okay, now these we may come back to this, but this shows in non-loading bearing walls. I'm sorry, but I couldn't find one that said in load bearing walls. Okay, and then we talk about flat insulating concrete, laterally supported top. Bracket 5, flat insulating concrete form walls shall be considered to be laterally supported at the top of the floor joists according to Article 9, 2017, 5. And basically, this is what they say. You got to be embedded in here, in masonry, in the wall, anchor bolted here, there. So that's how you say it's laterally supported. Okay. Now, reinforcement for ICF walls. Okay, they talk about the horizontal. Okay, and they talk about the vertical bars here. And the horizontal bars will be these are for foundation walls. Okay, so you got to remember there's a difference between foundation walls and above grade wall or non-foundation walls. Okay, because I believe that there's probably more soil pressures on it. They might want a little more reinforcement. So you get a 110 M bar, not more than 300 millimeters from the top, and a 10 M bar, 600 meters on center, and located inside the half of the wall section, a minimum cover of 30 millimeters. Okay, and then this vertical, your vertical reinforcement bar will go off depending on what thickness your wall is here. That'll go off that table. For example, like if we use a 6-inch wall here, I got a minimum vertical reinforcement of an 8-foot wall, 10 M SAR. I'm not sure about this table because there's a little bit of a question. I tried to figure out what it means, but they talk about maximum unsupported basement wall height. I'm not sure if they're talking about a knee wall or what, but kind of throws me a little bit for a loop on that one. I'm not sure. Again, it said it shall be laterally supported at the top and bottom, and now they talk about an unsupported. So that's where the code is a little bit unclear on that. So let's just gonna skip back to this other image here, and you can see that would be for that's for a non-load bearing wall. We want a load bearing wall, but I didn't find a picture in the user's guide for that. Okay, now the other thing that the code talks about, so we've got our vertical and horizontal bars, and they talk about a lapping of bars, okay? And so be lap 400 for 10 M bars and 650 for 15 M bars. Now it's when you're on your walls, how you'll have a bar that'll come together and they need to be lapped, okay? I would also say that besides the walls, you need to have them lapped in the corners. I don't know if you can get that distance in the corners, but they should be lapped or tied because they don't talk about L brackets in the corner. The building code there. So let's just go to the next one here and see there. We continue down with these tables. They still talk about the unsupported basement wall height. Again, is that I don't know where that's coming from, but again, we would assume that these are supported. I'm not sure. Okay, and then they talk about the 150 millimeters for finished floor above ground level. So that's pretty standard. Okay, and then we're going to the above ground walls. Okay, so if you're going to the above ground walls, then you've got a 140 millimeters and a constant height of the wall. And then you've got thickness of concrete shall not be contact with the ground shall be not less than 140. Okay, that's same as a regular foundation. Horizontal reinforcement in above ground insulating form walls shall consist of 10 M bar, 10 M bars, 600 millimeters on center. Okay, and the vertical bars they talk about there's no table for the vertical bars here. So we would talk about that and say that it's consistent of 10 M bars at 400 millimeters on center. And shall be, okay, so now when you get, we'll talk about in the next session, but when you get a vertical, that's like an opening in the wall, okay, you're not more than 600 millimeters from each side, so you have to make sure your vertical bars are within that distance of that opening. So we'll get into that, but again, besides you get the horizontal placement, you get the vertical placement, then you get the placement for your windows, okay, or your openings. Now those, I'll just go back here to openings. When we talk about openings, walkout basement would be a large opening, so that would be an on-supported wall. And so a walkout basement, you may have to go back to the ICFMA manual when you look at the a walkout basement. I would suggest that you probably do that anyway. Okay, and then we talk about anchor bolts. Okay, now yeah, okay, for flat ICF, not in concrete. See, this would be for not in concrete. This would be for above ground wall, because it's not in contact with grade, and that's out of the user guide. So they talk about, see, there you go. If you got an opening here, you got 600 millimeters to the next bar, and vertical bars are spaced, that spacing, and horizontal bars are there. Okay, so that is an indication of where your bars should go. And they also talk about anchor bolts, okay, on this. And the anchor bolts, they'll give you a spacing based on the anchor bolts shall be in a secure boards to flat insulating concrete form walls shall be embedded in the depth not less than 100 millimeters and spaced accordance with 920-17.5. Okay, so you have to look at your clearest floor plan and then figure out your anchor bolts in there. Okay. And this, a little bit of picture out of the user guide again is that we've got an anchor here, a ledger here, and then we've got an anchor here and a plate here. Okay. So that just gives you an indication of how they want the anchor bolting. And they talk about anchorage of building frames, okay, and they talk about the foundations on this, and I believe the other one was more specific to ICF. Anyway, your anchorage, they talk about the anchorage again on another section of the code. And then if you're in a high seismic where you have to have a wall band, it'll talk to you about your anchorage there. So you may want to go down and look at it, because there is if we just step back here for a minute, I'll show you here. Okay, so we get framing supported on the concrete ICF walls, okay? And then they also talk to you about just normal framing on the anchorage. So you have to marry the two. I would say you go with the ICF one, or the more restrictive one would be the best avenue to go. Oh, sorry. Now, I got a question for everybody here on the ICF. Now, if I take this wall here, the one on the left is an ICF wall, okay, and on the right is a normal wall. You've got two construction methods, both supporting a wood frame on them. One's requiring rebar and one is not. I don't know. It's one of those things that, do you require a rebar for an ICF low grade supporting a wood frame? Don't know. It's no different than the concrete wall that we have supporting. I think the building code is kind of unfairly treating ICF myself, because again is that we can have a concrete wall that's supported at the top with lots of rebar, but now because it's reinforced concrete, we have to go to a different method. So I guess for building inspectors, if you're supporting a wood frame at the top and a concrete floor below, you may want to have a look at that. As you can see here on the thickness of solid concrete, which would be a normal wall, not an ICF wall, right? We can go up on less than 8 foot 2 inches. With an 8-inch thick wall, we should be able to go 7.5. So why couldn't we not do that on an ICF without the rebar? That's a question I don't know if I've got the answer for, but just throwing it out there for you designers and inspectors. Okay, we're going to talk about the Icfma manual. Now, let's say this is a new manual, and I want to thank the folks at that worked on this manual. In particular, I want to talk about a couple folks that have been helpful walking me through their Mortesia. He's with Tacoma Engineering, a great guy, walks me through some of the stuff. And again, is it Kevin Nudora is another source of information. But if you're having a problem with this, reach out to your supplier, have a chat with them, and ask some questions, because once you understand it, it makes life go a lot easier. And you can see, as the code says, that we're doing it as part 4, okay, either part 9 or part 4. And in part 4, we've got all our various stamps, and for all the different provinces. So again, is that if you stick to your tables on this design, you've got it covered because they have all the stamps. Now, in the manual, they talk about a limited 1 floor below grade and maximum 2 stories above, which reflects the building code. Now, these note sections are must reading, because what happens is that the note section, they sprinkle some of the design stuff in these note sections. So you may be looking at a wall, but the note sections will tell you something else. It will tell you a little bit of no. Okay, so, for example, here on reinforcement steel, it tells you how you substitute bars, right? You can do that. And the lateral supports should be the same as the building code. So I would highly suggest that you read these there and make some notes. And you can see where like the bar lap length is and the standard hook length. So those things they won't tell you in the table, but they will tell you in the notes. Okay, now that was another one that I got stuck on here, was because I knew from previous constructions there's always a bent bar that goes in here and bends around. But I couldn't find it until it was located in the notes, right? So the notes will tell you that there's your bent bars, okay? And I won't go through each one of these. I've got some of them highlighted, and we'll go through those in the next section when we're talking about holes in the walls. Window and door openings, same lintels, it's all there. You just need to go through it, highlight it, and understand it. Okay, steel, provide one continuous horizontal, a maximum of 6 inches from the top of the wall on the floor level. So, again, you need to go through this and understand it. Laterally supported walls, wood ledgers, so it's all there. Anyway, they give you some pictures here. Laterally supported wall, they give you an indication how it's laterally supported at the top and the bottom, okay? Maximum, okay, so they'll talk about the maximum height of a finished ground from the floor, and they'll give you that picture there. And so if you've got a wall thickness 6 inches and you're less than 8'2", which is the same as the building code, your maximum height of finished floor can only be 5'10" or 7'6". So you need to look at that and understand that one. Okay, a knee wall, for example, okay, unsupported. They're talking about how they deal with knee walls, and we'll get in there. They give you a diagram for a ledger detail and a table for that on your bolting, okay? So tie spacings and floor span, same as the building code, but a little bit clearer in how they want that handled. And then they talk about brick ledge and stirrups here, and then how they bump it out here, okay? And the placement of the bars, okay, so there's lots of great information in there for us. Floor ledger anchor bolts, okay, again, we went through that. Okay, so here's where we get into this below grade wall distribution reinforcement seismic zone. So that's where you need to know your seismic zones, okay, less than 0.25. and your hourly wind pressure, right, with 6-inch tie spacing. So that's where all that information that you have. And once you get that for your local area, it's fairly straightforward. Okay, so we look at our wall height, it's 8 feet, right, backfill height, and then this will talk about the vertical bars, okay? And then when they talk about backfill fluid density, which is that we go down to 300 or 480, because if you've got a drain tile in there that's free draining, you don't have any back pressure. Basically, it's all free draining and drains out to there. So that's what they tell you there, and I believe that is in the notes. Okay, so that'll give you. Then you'll look at the vertical replacement or reinforcement of the bars, and that'll talk to you there. Okay, so that'll give you all the information you need. Now, we're talking about walls without any openings. Okay, and then we talk about above grade walls. So we got the below grade, now we got the above grade, okay? And then you got to deal with your hourly wind pressure, your wall height, and your wall thicknesses, and you got vertical and horizontal. Pretty straightforward. And then you'll combine that again with your note section, right? Oh, another one of those things. Okay, so the only thing that I've got a bit of talk to you about is the when we get a wall here, like you got a wood wall up here or something, a wood floor and a wooden wall, and sometimes the builders will try to hang this out over the foam. That's not a good idea, because you get this bottom plate in cross drain tension. Okay, so what the better idea is, use a bit of a fluted top on here and with an anchor bolt, and that way everything bears on that a little bit on there, or you can pull it back so that everything rests right on that concrete. But you don't want any, if you can help it, you don't want any bearing on that foam. I know that the code talks about the bottom plates can be hung out a little bit farther, right? But again, it's a good idea. You need to pull it back or to get it supporting on something. Now, the other thing is that Simpson's makes a product that's not referenced in the code or anything, which I think that we should give a look at and see if it'll work. Okay, they have anchor bolts, they've got ties, they have a whole system for ICFs, and you can see how this one here, how you can put you bed this in the foam, and this gets screwed in with the special screws for your ledger board here. I don't see any issue with these things, but again, they're not laid out in the building code. And you can see how they've got various tie downs for your trusses, straps for here. So again, it's that they offer a full range of anchors, and I would assume that Simpson and then MyTech, who are now into the connection business, would also offer the same, but the code doesn't deal with those. Again, I just want to thank everybody for this sort of short little bit of the data on the rabbit hole on walls. I do think that the building code has missed the mark when it comes to ICF. I would say that in the next reedition that they maybe use the Icfma Manual or something, because again, with some of it's not very clear, and again, is that how are they distinguishing between a normal foundation and a ICF foundation? One's calling for rebar and reinforcement, supporting the same thing as your concrete wall. So I think that the code needs to revisit that, and as building inspectors, the designers, I'm not sure how you handle that once you know that you're going to have a wall there. And if anybody knows any answer, just email me. I'm a building inspector with the town of Rothsay. Email me at Steve Nason at the town of Rothsay, and maybe you can clarify it a little bit for me. Anyway, thanks very much, and we'll be going down that rabbit hole on holes and openings, and primarily focusing on shear walls and those things next session. Thank you very much, and have a great day.